As we have learned throughout the lessons in this course, stars go through many different phases and transitions over the course of their lifetime. When a star is new, it is relatively unstable and is classified that way. Stars begin their lives as something called a protostar. During this initial phase, the stars are still existing within their molecular cloud. Over time, a new star eventually develops, something that is known as a protoplanetary disk. When a star is in the early stages of forming, the star is able to shine with just the gravitational energy of the star's collapse. Astronomers call this pre-star a Tauri star. All stars in evolutionary stages are characterized by emission line spectra and strong stellar winds. Stellar winds and radiation eventually blow away any surrounding gas or dust. After all of the gas and dust is removed, the star is then in the Tauri phase. The stars within the Tauri group are a class of variable stars that are less than 10 million years old. This class is named after a prototype, Tauri, which was a young star in the Taurus star-forming region. They are found around molecular clouds and are also identified by the way they have optical variability as well as strong chromospheric lines. Tauri stars are known as pre-main sequence stars in the process of contracting to the main sequence along the Hayashi track, which is known as a luminosity-temperature relationship followed by infant stars of less than 3 solar masses in the pre-main sequence phase of stellar evolution. It ends when a smaller star commences nuclear fission on the main sequence. So what are the stars that fit into this classification? The T-stars encapsulate any star within a class of young stars that have a mass of the same order as that of our solar system's sun. As I mentioned earlier, the stars are named after a prototype identified in a bright region of gas and dust that is known as the Hines Variable Nebula. The Tauri stars are characterized by erratic changes in brightness. They represent an early stage in stellar evolution, having only recently been formed by the rapid gravitational condensation of interstellar gas and dust. These young stars are relatively unstable, though contracting more slowly than before, and will remain in that condition until their interior temperatures become high enough to support thermonuclear reactions for energy generation. More than 500 Tauri stars have been so far observed. Some who study the sun have even said the sun in our solar system is thought to have gone through the Tauri stage in early life. About half of the stars in the Tauri group have something known as a circumstellar disk. These actually have a specific name of protoplanetary disks. This is most likely because they are the progenitors of planetary systems, like our solar system. These disks are estimated to resolve or dissipate within 10 million years. Funny enough, the Tauri stars appear very similarly to the main sequence. The Tauri stars actually appear more luminous because of the size of their diameter being larger than other stars. Some have discovered that due to this energy provided to the Tauri stars coming from gravitational collapse of the material within the star, the stars end up with sunspots on the surface. Throughout the following 100 million years, the stars will eventually begin collapsing until the pressure and temperature overall is enough to begin or ignite stellar fusion. When this starts, the star is beginning to convert hydrogen into helium, and after this is completed, the star is considered a main sequence star rather than a Tauri star. Although our sun is said to originate from the Tauri stars, a star like our sun will continue as a main sequence star for approximately 12 billion years.